Hi, I'm Tom and I talk about code. Welcome to another Rust livestream where today I'm doing even more work on my compiler, implementing structs. We're close, we're getting really close. Today we're going to finish off the right-hand side of the equals sign. Last stream we got the left-hand side working, so we can say something. If we have a struct foo, we can say foo.x equals 5. This is done. But what we can't do is say y equals foo.x. Not yet. I don't want to put a cross. Crosses are kind of scary. That's not the energy I want here. So this is what we're going to try and finish today. Now, the observation I made. When I say that I've done this, there is a caveat. Okay, the caveat is that I have not done foo.bar.x equals 5. Right? The middle step is illegal. We're not doing that yet. Because it turns out that the algorithm to step through these things, it's not hard, but it's also non-trivial, because if this is a pointer, we have to add code to dereference a pointer before we can assign. Whereas if it's not a pointer, we can do all of the offsets at compile time. So it's interesting. It's interesting. Interesting problems. This, on the other hand, I'm going to try and actually do. So, no. I'm going to put a cross there so we remember, no. But maybe at some point. This, on the other hand, I want to do. I want to be able to say y equals foo.baz.x. Okay, and let's draw this out as an example, because this is going to be important. So let's say foo has type foo. And if foo has a field, it has a pointer to a baz, which is called baz. A bar. Oh dear. We'll call this bar. We'll use the correct order, because that'll be more logical when we follow it through. We'll call this bar. So a bar is a struct, and this is going to have a field baz. It's going to have a baz that is called baz. And this one isn't a pointer. And then baz is going to have an int field called x. Okay, so with these definitions, we can walk down this chain and work out what x is to assign into y. Now, how do we do this? So, foo is a variable. Let's say it's not a pointer. So this variable is still going to be a pointer, right? Even if it's a struct value, we get it by having a reference to like where this is as a local. So it's kind of like a reference to it. So we say foo, and we can turn this into an address, right? We can load that address into, say, the C register. Okay, so now we have an address in the C register. To get to the field bar, we need the offset of the field bar. So then we want to say add to C offset of foo.bar. Perfect. So now we have this field, the address of it in register C. Now what is this field? This field is a pointer to a bar. So to get a bar, to get the start of the bar, well, again, what's this pointer? Well, it points to an address in memory. So to get a field out of a bar, well, this is a pointer to a bar, we need to add whatever the offset of field baz is to the bar. I picked really bad names for this. Infinite Coder says, why don't I have a compiler tag? Is this like on my stream? That's a good question. Why don't I have a compiler tag? Let me do that right now, while I mull over my poor life choices of naming these bar and baz, which are very confusing to reason about. Is compiler a tag that people look at? Compiler. Yeah, awesome. Hello, welcome. Okay, we've done that. I am now a compiler streamer officially. So we have this address, right? This address points to the start of a bar structure in memory. So now if we add to C offset of bar.baz, right? It's actually the same thing. Even though we're doing this by value, we're doing this as a pointer, it's kind of the same thing. And then we get a baz, and again, from the start of this structure, so what we point to in memory is actually the start of this structure, so we just add again, the offset again. Ah, you're looking for people to raid for other compiler devs. That's a good idea. I should probably use tags more for that. I've raided some really random people. I raided Mr. Weeble, like the Flash Badger song guy. That was fun. We didn't know what was going on. So, in other words, we just keep adding the offset of the field, regardless of whether it's a value or if it's a pointer. But the thing that I've neglected, the thing that makes that not, like, that didn't sound right in my head, and it in fact is not right. Because here we have the offset of the field that is a pointer, so actually in the middle, we need to dereference. So every time we have so all we do is continue to add the offset of each field, but if this field's a pointer, we have to dereference it before we continue to add the offsets. Awesome. So that's all we do. And that will actually work on the left-hand side as well. That will absolutely work on the left-hand side. We can generalize this, but we're going to do it on the right-hand side first because I have stratified the left-hand side. So let's just build and see where we are. I don't think we're building right now. We're not. Nice. Field deref. Yeah. Cool. So we started doing this. Lots of people use different... Oh, whoa, I'm trying to pull chat up onto stream, and you can't see it because I'm on the wrong scene. And you couldn't see what I started talking about then because I was on the wrong scene, because I always forget. Infinite Coder, thank you very much for the follow. Compilers tag. Yeah, we need to standardize, okay? Where's the Twitch TV Compiler Writers Union, where we standardize this stuff and, like, you know, all back each other up in a fight? Right? That's what we need. Okay. So, we're going to dereference a field, and we're going to do it. And we're going to have to engage our brain really, really hard, but we're going to do it. This is iterative. There could be many fields here. Oh, except my observation was that... And actually, this is important, because I tried to do this iteratively for the left-hand side, and it was complicated. I forgot I wrote it like this. The observation that I made is that... Like we're taking a field of a thing, and this thing is just an address. Like, we just add an offset to an address somewhere, and the thing we're adding to is just an address. So we can kind of subdivide this down. So that's what I'm going to try and do. I'm going to try to resolve the left-hand side, right? This also means that in theory you could say like 5.x, and it would, but it wouldn't, because 5 wouldn't have the type. So we get the type of the left-hand side. Let's park the value of it for now. Assume we get the value in register C. C is our kind of scratch register. This is compiling, by the way, for my own 16-bit virtual machine that I've also written in Rust, so that's fun. So we're going to get a... Switch the screen. Thank you. I always do this. I literally have this up on my second screen and I still somehow miss it. So I thankfully didn't actually write any code. I just wrote a comment. Excellent. So we're going to assume that we have the value of the left-hand side of this expression in register C. Then all we need to do is say if type.is struct. So actually we need the field. So we'll say I'm going to say let fields... I did this before, right? We need to get the fields of the struct so that we can look up the field that we're trying to dereference. So we're going to say let fields equals, and then we're going to put a block here. We're gonna make a sub block. We're going to say if let sum... not sum. We're going to say if let type struct. It's hard because struct and sum start with the same letter. Fields... So if this type is a struct, then we just give back the fields of that struct. Otherwise, if let type, otherwise if it's a pointer to a t, and that t, we have to do it like this because this is a box of a t. and we can't nest. Like, I would love to just nest this and say like type struct, but we're not allowed to do that. That's illegal. The Rust police come and hunt us down for that. So we're gonna do it like this. This returns fs. Otherwise, return error, and then we also have to have an else down here that returns an error. Actually, but then this won't all have the same type, will it? You can actually do this. 2 years later, buying silicon to build a 16-bit CPU. I would love that. I would love that so much. That would be a lot of fun. I can do this. If you know how to do this, I would love to see it, because when I tried last stream, it didn't work. Also, how did I do this? So I'm going to put a mark here, and I'm going to jump down to my statements. It's the field, assign struct field. How did I match? I got the variable type. Return error. Oh no, that's okay. I guess I can do it. Okay, I guess I can return in the other branch, and it'll just work it out. Look, I'll try this. Okay, for the sake of experimentation, I will try this again. But because it's a box, I don't think this pattern will ever match. It would be nice. I would really like that. It would save me writing some stuff out. Did I put a mark here? No. Assign struct field. What error did I use when it was the wrong type before? Non-struct field reference. That's excellent. That's exactly what I want. Where did my mark go? Wonderful, wonderful. I lost my mark. I somehow deleted mark A. So non-struct field reference. Oh, maybe with ref. Yeah, it's a box. It's a box. Ref. No, I don't know. Nastya NVR. Hello. Welcome. Welcome. We are compiling really, really hard. I'm going to change this back. You've shaken my confidence. If let type struct fs equals t, then we just give back the fields. Else we return error. Else we return error. There's a bit of duplication here. We're going to have to, I think, 4. Nope. We're going to have to resolve that, but that's okay. So this is field. No, it isn't. I guess it's this thing, right? Whatever's on the left-hand side is not a struct. I can do type pointer. Else. I don't know. I don't think this works. I've gone back. I've committed back the other way now. Thank you. This is Groupbox. Groupbox and something mono. What is it? I always forget. Droid Sense? It's one of those. It's very clean. I'm very happy with what I've done. And the type is ty, and then same thing here. We're going to have LHS and ty. It's a little bit ugly, but we will survive. Okay, so we've got the fields in a variable, or we've jumped out of this whole function with a very important type error. So we have the fields. We can fields get field. And then if we don't get anything, this is an error. So we'll say let, and a field is just a tuple, I think. This is in fields. Is this in type fields? Oh, this is in resolve. This is in resolve. Yeah, Groupbox is a good theme. Groupbox has just really nice, easy on the eye colors. I actually use Nodebox sometimes for my personal stuff. Struct fields type size. Yeah, Nodebox is nice as well. But this is really good for streaming. I think Groupbox encodes really, really well. Cool. So we're gonna OKR. So if there's no field, then we say. I think I'm using undefined variable for this, which is, yeah, variable undefined. Which is not the correct error, but it'll do. And we'll just use the name of the field. Cool. So we have the offset. All we do is add this offset to the C register, right? Or do we? This field is, so dot. So I've ignored the, well, So what's actually happening here? So we've stepped through the type of the left-hand side, which is, this is going to be a little bit recursive in a sense. We have the fields associated with that type as a struct, only if it's a struct, otherwise it's an error. You can't field dereference something that's not a struct. Then we get the offset of the field. So I need to go back to my picture here for a second. So we've done this bit. So what's in the C register is, in this instance, it will be a pointer to the start of a baz. So all we have to do is add to it. Now, what if we stopped here where it was just, what if we stopped here where it was just foo.bar? How would we deal with this? Or foo.bar dot baz, right? Where bar, well, the type of foo.bar is a pointer to a bar. Yeah, so this is where we need to think about it, right? So this would be our left-hand side. Sorry, this is getting very noisy. I've got a lot of color going on. But so this is a pointer to a bar, so we need to do a dereference. So we need to say if the left-hand side, we know the left-hand side. Oh no, sorry, so it's the type of the left-hand side. Sorry, so what I want here, yeah, so if LHS, if type dot is pointer, then I want to deref before I add the offset. I want to add an instruction. I want to load a word. I want to load a whole word for a whole address. Oh, switch screen. Thank you. I'm actually the worst. I don't know how I keep doing this. Am I handling spans for errors? No. Errors, they just bubble up. They're very primitive errors right now. Switched to VS Code a few months ago. You get way more indifferent stuff. Yeah, you know, if it works for you. When I was doing full-time Golang backend dev, I was using a JetBrains IDE. That's usually what I've done. And now that I'm just, you know, not working at the moment, I'm playing around with Vim more. NeoVim. Recently tried Zed. Zed sounds cool. Set up a Twitch bot which lets us switch screens. Yeah, you can redeem chat points to fix my setup. That would actually be great. That would be perfect. Very practical bot. Zed sounds interesting. I don't think I would swap to Zed in a hurry. If I get a job, I was talking to a recruiter today. If I get another Go job, I think I will maybe try and do it in NeoVim if they let me. You'd think I need a read chat command. It's hard because I'm also thinking about the wonderful YouTube viewers who are following this along, who are following along with the VODs. So I'm kind of managing how much I yap and how much I code. Okay, so we need to dereference what is in register C. Did I spell one of those wrong? Register, good. Right, so we take a reference to a thing. If this is a pointer, we need to resolve it, and then we add the offset of the field of the struct. Or do we do that as part of this step? Okay, I actually need to think about this part now. This has become very important. Let's write a sub-function for this. Let's just call it load. What do we call it? Let's call it maybe load value of. Well, hold on. No, it's just compile expression. I already have a function that does this. It's called compile expression. And if the left-hand side of this is a field deref, yeah. So compile expression. Compile expression. We take a context. We take a scope. We take a mutable ref to a scope. I think this has to come after this, and we take the expression, which is the left-hand side. Awesome. This now is on top of the stack. So we're not omitting any code between here and here. So now we want to do this. We want to say out.push. We want to pop it into the C register. So stack into the C register from the stack pointer, and we're gonna stack op pop. Convert all your NeoVim hotkeys to VS. Yeah, well that's good. That's, you know, obviously you're not gonna, even if you use a different editor, you're never free from the Vim style key. You can never leave. You can never leave. Okay, and then we just add at offset. And then that offset is, yeah, so I guess we add the offset and we dereference, but this doesn't work recursively now because, oh, you can leave if you try Helix. This is controversial. What is so good about Helix key bindings? What makes Helix good? Why would I, as a Vim user, try Helix? So if I evaluate foo.bar, I end up with a pointer. If I evaluate foo.bar.baz, I also end up with a pointer. I think part of my problem here is that I don't have a good representation of struct values. So they're all kind of pointers. I guess that's okay. I don't have the concept of a value that represents a struct, right? There's semantic difference in how they get allocated. So what that means is, if it's a primitive type, we dereference, and if it's a struct, we don't. So if we say if the type of, so this is where we need this type. This is where we need field type. If field type is a struct, or if field type is not a struct, then we dereference again. I think this works. This feels good. And now we have it on in the C register, and now all we need to do is push the C register to the stack. This is almost certainly not going to work. I can't imagine this working. It just doesn't feel right. It just doesn't feel right. We need to actually make we need to make outVec is vec new. We're gonna make a vector. We're gonna out.extend whatever the result of this thing is. Can we build it? We forgot to say equals. Couple of issues here, of course, always these semicolons. Mismatch types, this needs to be a ref. Okay, expected expression found box expression. Do I have to deref it? This expression has type box, so I think I need to unbox with a nice little star. This sounds good. Expected a, oh yeah, I forgot. I have a little wrapper type here. So we're gonna ref the data inside the field, and this is probably gonna be the same thing. Except I think we need to clone, or I guess toString it. Let's just say toString, that's easier. I think I have to do that again. Out to have type. Oh yeah, that of course needs a question mark. Okay, here we go. I need to actually return something at the end of my function. This is beautiful. I'm getting a lot quicker at dealing with all these. Helix key bindings make sense. Fast and easy to configure, 0 to LSP in 4 minutes, written in Rust. I don't agree with this. I'm enjoying learning Rust. This is controversial. Helix key bindings make sense, yeah. That, you know, it sounds interesting. I'm just very ingrained in Vim at this point. Expected expression, that's because I put a semicolon there, because I'm very silly. And I forget that I'm doing things functionally. Offset is not used. Now, it's because I forgot to add it. So here we need to push another instruction. And this is going to be an add immediate into register C. We're going to make a literal 7-bit out of this offset. And then we're just going to unwrap it because I don't have a good plan for what to do if it's too big yet. That's, you know, we're using unwrap to kind of mark that, yeah. This is a joke. It's honestly hard to tell with Rust people. I like Rust. I'm enjoying writing Rust, but Rust people, oh man, they can be something else. We're just gonna do this the really jank way. So, you know, this is one of these things, like it works. It works until we have an offset too high to represent in a U8. And then it's gonna, bug it. This is this thing again, hold on. I think this is fine as long as I put it here. I think. No, it's not declared as mutable. Oh, wait. I think that's because it's already a ref. Yeah. Okay. So we move out of the box here. But compile expression. This is annoying. Compile expression. Hold on. What am I doing? Where am I typing this? This should take a ref to an expression. It just should. I'm gonna break this literally everywhere because it's gonna kill me otherwise. Because we can get a ref to a box. These are gonna yell at me. I think these are boxes, so it's probably gonna say like it expects something else. But we can get, yeah. So this one will be fine because this is a statement. What is it gonna? Oh no. Maybe I borrow this one. What are we seeing? Yep. This all looks good. God, I compile a lot of expressions. There's a lot of expressions in programming. Now, I think this I need to... Can I borrow a box like that? Is that okay? I don't know if that works if it's a ref of a box. Found... that's weird. Oh, because now that is a ref. Yeah, okay. So we need to dereference I for this comparison, which is weird. Surely it's going to be sensible about this and not make me, you know, not do this deref every time. Surely it's going to optimize this. Instruction. How does this go? Expected expression, found box expression. Okay, so can I pass this? Is that happy with me? What else have we got? Clone, mismatch types. Beautiful. We can deal with that. I can fix that. Expression, found box expression. So we're going to try doing this. I think that's okay. I think that's fine. Again, I'm not really sure what the what the deal with borrowing is here. Now type of a field deref. This is interesting. This is really interesting because we need to know the type of, well, no, actually it's not that interesting. It's just we get the expression field deref. We have a left-hand side and we have a field, and I can't remember deref. Assign deref, field deref. It is not in curly braces. All we do is this awful thing again. I'm gonna copy and paste it. I'm just gonna do it. Copy and paste it. We're gonna get the fields. We got to get the fields, which is very unfortunate. Now, does this? Yeah, this doesn't return an error. So all we do here is return void if it's not a struct. Let fields, or we just return like an empty map, I guess. because then it'll fail, and that's okay. The default is just empty map, right? Because if we don't have any fields, then this will fail. Now what we want to say is, what rust up doc. Let's just grab the docs. I can never remember what the method is to give an option a default value. I can never remember. It's like unwrap or default. Yeah, unwrap or default. That's the one I want. Thank you. Infinite Coder got there about the same time as the docs, as me scrolling through the docs. I can never remember the name of this function. It's not even a hard function to remember. It's just I don't know. And we're just gonna give back a void type. But there's, wait, I need to map this, don't I? I need to map this t. I'm going to map it from a tuple just into a type. And then we're just going to return it. Cool. That's what we return. So this is the type of this whole thing. It's the type of, wait, no, hold on. Fields. No, wait, I did that wrong. What did I do wrong there? No, that's right. So this is I don't know. The way I've set this up is actually breaking my brain a little. This gives me the definition of the field. So I want to return the type of the field. What do I have here? We don't care about the offset. We throw the offset away. Okay. And then we'll say, oh yeah, no, this is what I want. Fields.get. Yeah, because we're getting the field off the, yeah. No, sorry, I was right. It's okay. Nobody panic. It's okay. What happens if I build this now? Well, I get yelled at for forgetting a colon, of course, obviously. I always forget this second bar to close the closure. This is, oh yeah, of course, sorry, I forgot this other thing. Let type equal type of tie, except we have to pass in the context, the scope, and, sorry, the left-hand side. P partially moved here, partially moved because this is part of a nested thing that's part of, that's okay. What we can do is this. This is really dumb, but we can do it. Can we? Wait, but hold on. Why is this a problem in the error case? This is value borrowed here after partially moved here, 6. I hadn't saved the file, that's okay. 39, this is the same thing, just in a different place. 6, expression, 9.3. What's it saying? 693, so we partially borrow it here. I'm just going to clone again, just for the sake of moving forward. Trait default is not implemented for resolve.type. That again is because we have to do a clone because this is a ref. Or default, no, sorry, hold on. Unwrap or else is what I want. Default. Wrong word. Unwrap or else. Default probably isn't bad there either. I don't know if I want void to be the default type. Sorry, unwrap or. I'm overcomplicating it again. Unwrap or else expects a closure. Unwrap or just wants a value. And that works. Cool, so let's remind ourselves what test I was trying to compile. This looks okay. So what happens if I say y.len? Okay, what happens if I build this? It's gonna yell at me about something. Expected token y.len. It doesn't like parsing this. At all. Now, I'm pretty sure I wrote a parser for this, but it was after midnight, so I can't actually remember. This is the danger of late night coding. Let's go LHS. Expression left-hand side. Car, call, address level bracketed. I don't think I wrote a parser for a struct field. So let's do that. Expression struct field. And we'll call it fields. And this is going to be a lot like a statement that gets fields. Indeed. We're gonna start by copying and pasting this. All good code is midnight code. Yes, but not all midnight code is good code. This is an important life lesson to learn. I remember this is really random. I was on a steroid for a little while to treat a medical condition that I have, and I was on a steroid called prednisolone. And they gave me, I was really unwell, and they gave me this really high dose of prednisolone, with no warning. Or they were like, you might feel a bit funny. And then I start taking this steroid. I hadn't thought about it much, which, is kind of my fault. Struct fields, hold on, what's going on here? Expression. Oh yeah, sorry, this is what I want. So, an identifier and then repeated dotted fields, yes. Cool. And this list. This is actually kind of the opposite of how I want to do it, but that's okay. So I start taking this oral steroid, and I knew none of the side effects. I had not been adequately briefed, and it turns out like I was awake until like 4 a.m. for many nights in a row. Like I hardly slept. But one night I was like, okay, I'm not sleeping. I'm gonna write code, and I sat up and I wrote a terminal-based spaceship simulation. Like you had this text-based display, and you had little spaceships that would fly around in space, and a couple of like asteroids and stuff. And I was gonna turn it into this whole little game thing, but I was just like, fuck, I just have to write this. I couldn't sleep. I couldn't relax. I was so wound up, and like manic late night coding. I just wrote this whole thing in one sitting. It was incredible. I've never really had a moment quite like that again. Don't recommend the meds, but if you're ever on them, just get some coding done. It's the one upside. Okay, it's called field deref, and we want like the opposite of this. We want. Oh yeah, hold on, no wait, I just do this differently, don't I? This is an expression followed by a dot followed by. Okay, this is really weird because my parsers have just completely diverged. Right? They've gone in completely different directions. Like this different approach to evaluating the expression means we actually have to parse it in a completely different way. So we're going to start from scratch. We're going to say, we're going to get an expression, right? And we're going to grab I think this has to be the left-hand side of an expression. Is that right? Does that make sense? Does that mean that Let's try. There's a recursive problem with parser combinators. This might not work, but let's try it and see what happens. Expression. Let's just say expression. Let's see what happens. Okay. If you're new to this code base, you will get the privilege of enjoying my manually written out monads. Right? This is a monadic structure, and I'm writing them out entirely expanded because I like pain. Okay, so we parse an expression, then we parse with no space a token dot, and then we parse an identifier. Oh, and still no skip white space, just identifier. Wow, I don't think there's a single other place in this whole code base that I just grab an identifier. A monoid in a category of endofunctors, not a function, a functor. Very important distinction. But that's all you need to know. It's just a monoid in a category of endofunctors, and that joke literally never gets old to me. Never gonna get sick of telling it. Cool. So we make a box, we put our expression in it, and then we chuck this ID in here. And I think we're good to go. And I build this and it works. And there's no errors. No errors at all. Nothing goes wrong. because I didn't forget to fix my copy paste. And then I need to actually, I guess, use it somewhere, right? I need to kind of, maybe I'll put this at the bottom because it's a very flexible parser. It's gonna consume a lot of things if I'm not careful. Okay. Expected a confidence error. Yeah. I've got to wrap this up. I've got to, with confidence. Because I've seen a dot, maybe this is like confidence medium. Right? And confidence in this case is just a thing. Oh yeah, that's not how that works. Confidence in this case is a concept that my error system uses to know how sure we are that this was the error that occurred. Parser is confident, yeah. So the idea is that, like, we have this list of things, and so we try all of these expressions, and some of, like, either one of them passes, or they all fail, right? Those are the two cases. So we get a list of all these errors. Actually, a more obvious example is the statement. Where's my big statement block? My big statement block, right? So if all of these fail, we just get a list of all the errors that came with these. And how do you know which one is the most relevant error? Well, if we saw if we saw the token if, then we're pretty confident that this was attempting to be an if statement. So we don't want to show the error for the while statement, right? We don't want to show the error for the assignment. We want to say, hey, this is not an if statement on this line. So it means that we can filter out the errors that aren't relevant, because we can find the correct thing by trying everything until one of them passes. That's the parser combinator way. So yeah, we fail forward. We fail forward. I'm going to make my tests and see if this new parser broke things. And it looks like it did. It looks like it did. For one thing, I doubled up. But if I make my tests, yeah, we overflow our stack. So some of these tests are struggling right off the bat just to deal with the existence of this. And this is because it's on the left-hand side. So I'm going to put this out here, and this will limit, struct deref, this will limit what we can parse, but it will also mean that we don't end up in an infinite loop. And that's quite important to me. Not ending up in an infinite loop, fairly high on my list of priorities. Expression struct fields, my mistake. Manual recursive descent passes for the win. Yeah, all I know is parser combinators, and you know how it is with coding. When all you have are parser combinators, everything looks like a nail. So that works now, right? That works now. You know, basically, I'm hoping to make this not awful, right? Because I've heard there are limitations to parser combinators, and I'm discovering what some of them are. One of the other hard things is that if something goes wrong, it's really hard to continue parsing. And I've got a little solution for that. I'm gonna come up with a solution for that. Well, I'm gonna implement a solution for that, and it may not work, but I'm gonna try it. So we need a test for struct fields. Struct fields. My tests are a little bit Spartan. They need a lot of work. They need a lot of cleanup and a lot of fleshing out, but that's okay. That's okay. We're gonna parse struct fields. We're gonna say foo.bar.baz.xyz. Okay, this should parse. This should parse with our expression struct fields. It should be round trippable. And if I test it, it's gonna yell at me because I forgot the letter T. So yeah, Infinite Coder, I'm assuming your language is using recursive descent. What is your language? What are you doing? What's your vibe? What are you interested in? Because like I'm just doing C, right? This is not this is not ideal. This is not ideal. Yeah, I'm just doing C. That's it, really. There's nothing too fancy to it. Dev Ninja, welcome. Thank you for stopping by. We are on a journey of self-discovery. Field deref. Okay. See, field deref is an expression, but oh, wait. I see what happened. Okay? So when we test this, we see foo.bar.baz.xyz, right? This is what we're trying to parse. What we get is foo.bar. So what happens when we try and parse this? Well, we run, evidently, our struct field parser, we see an identifier foo. Awesome. We then see a dot. Awesome. This is a valid expression. This is a dot. We then see another valid identifier. Perfect. We're done. That's it. We have a field reference. So I need to play with the ordering of these parsers. I might need to try this first. I might need to try to do this first before I try anything else. And we're still not going to be able to have them on both sides of an equal... Oh, no. Yeah, we can't have them on both sides of a plus. We can't say foo.x plus foo.y. That's going to be illegal. Unless I then write a third function which has all of these except... I don't know. Maybe left-hand side isn't the right word. Maybe I need one that doesn't have binop and one that doesn't have struct fields, and they can live together in harmony. But this should work now. Because... Oh, wait, hold on. We try and grab... No, the left-hand side needs to have this as well. Oh dear. Oh dear, we're in a corner. Oh dear. Okay, so... This isn't great. This is a real problem. This is a real problem. So we need to parse a thing on the left-hand side that could as well contain this. Now with the binary operation, we force it onto the right-hand side, right? We say that, okay, the left-hand side cannot be a binary operation. So it's a thing, then a binary operation, then another thing, which could be another binary operation. But this time we're trying to offload that onto the left. And that's tricky. So... Oh, that's so annoying. That's so annoying. This is a limit. This is the kind of limitation of parser combinators that people warn you about. If only I'd listened. You know, it's getting serious. I gotta put a jacket on. Yeah. Code structure in my head versus code structure in reality. Amazing. Man. It's... Oh, Dev Ninja, thank you very much for following as well. I hope you're enjoying this madness, because it's about to get really, really silly, because we got to come up with a solution for this. We have to. If I want structs to be done, we have to. So. It's hard because it just has to be an expression. There's no other way. Oh, awesome! You're planning your own language. Sorry, I'll look at this link as well. Maybe towards the end of the stream, I'll put it in my little paste bin. In the process of what language are you planning? What kind of language are you looking at? My advice is don't do what I'm doing. I don't know what I'm doing. I'm making this up as I go. I need an expression followed by a dot followed by a thing, but I want that expression to be able to be this thing as well. Why doesn't that work? Why? Because we look for an expression. So the reason this doesn't work, okay? If we call expression struct fields, the first thing we look for... Don't do parser combinators. Fair. If we try and parse expression struct fields, the first thing we look for is an expression, which could be expression struct fields. So the first thing we look for is an expression, which could be expression struct fields. So we look for an expression. The first thing we look for is an expression, which could be an expression struct fields. There's nothing to stop us doing this forever. Is there something we can put here that would break that loop? Is there something we can put here that would break that loop? The problem really is that it's first. The problem really is that it's first. I'm going to do something silly. I'm going to do something really, really dumb here, and it's going to fix it, but it's going to be dumb. So I'm going to grab an identifier. We're going to skip white space. Identifier. The first thing we do always has low confidence. We're going to grab the input. So we have an identifier. Then we're going to copy what we were doing in fields. We're going to copy what we were doing assign struct fields, this thing. We're going to grab this. Okay, now. Wait, where was... Yeah, and then we're going to put something at the head. Excellent. Okay, so now we have a list of fields separated by dots. We can work backwards from here. Your language is mostly going to be TypeScript because you love the module system. Some other nice stuff. Name constructors from Dart, enums with members, pattern matching. Nice, nice. That sounds like a better direction to take TypeScript. Modules are interesting as well. So I have specifically put modules and imports kind of out of scope, right? The idea is that this is a programming language for a small virtual machine for small programs. So maybe like C-style glob files together and just compile them in one go. Because it's a 2-pass compiler, well, actually a 3-pass compiler, I guess, you don't need to forward declare function headers, right? So like function definitions, it will resolve them as the last step of the compiler, which is cool. Which is why all of my code gen has all these wonderful, if you look at them, unresolved instructions. That's because instructions can reference things that aren't resolved until the last step of compilation. Okay, so now that I have a list of dot-separated fields, I'm going to work backwards to build these expressions, which is just so awful. I'm going to need a helper function for this. And this function is going to be called... It's going to be called... build struct fields. We're just going to call it this. We're going to take a slice of identifiers with the assumption that they're dot separated. So we're going to have, it's going to be called fields, and it's going to give back an AST expression, and that expression, so we're going to say the thing we give back if fields len equals 2, so if there's a dot b, then we give back AST expression, whatever this thing is called. What did I call it? Field deref? Field deref. I guess I don't know why I called this field deref. That's a bit of a silly name. Anyway. The left-hand side is going to be a AST expression variable. And that variable is going to be fields get 0.unwrap because we just checked the length. We know this will succeed. And the left-hand side is going to be fields get 1 unwrap. Excellent. Okay. If fields len greater than 2, then we want to give back the field deref whose left-hand side is this. Now we want it to be the tail of this. So it's 0 to fields dot len -1, I think, if not -2. And then fields get fields. Is there a last? Is there like a tail method or something? Let's say tail. This method might not exist. This function might not exist. Otherwise, this is not valid. This should not parse. We should never get here. There is dot last. Thank you very much, Infinite Coder. Dot last. Okay. So we have this dotted list of fields. We're gonna give back OK, S1, the remaining state from this, and build struct fields expression fields. And this will work. This is fine. This is fine. This needs to be an AST identifier, of course. Fields. I see no way this could go wrong. This fields get Oh, okay, this needs to be toStringed. That's okay. That's okay. Then I don't think that does need to be toStringed. Identifier found, expected identifier found identifier. So this just needs a clone. This will then also need a dot clone. And that's okay, that's okay. We have to copy out of this. I think we have to. I think this is the law. Expected box expression found expression, of course. Box expression has to be boxed, has to wrap that up nicely in a box. And this is also going to need a box, right? Box new expression. Wait, hold on. That was in the wrong spot. That box was a rogue box. I was boxing up too many things. Okay. How are we going? How are we going? We're closing in. Wait, what am I saying? Sorry, box new. I lost. You lose concentration for a second, and you're just off the rails completely. Build struct fields. Okay, expected identifier found identifier. That's because this needs to be a ref. Okay, now if I test, does everything work? We still overflowed the stack, which is weird. I wouldn't think that would happen anymore. I wouldn't think that would happen. I wonder what function we're in when we overflow the stack. Does that tell us? Rerun p-align. Can it tell us where it ran out of stack? I guess it just dies, right? It's just like, nah, that is fatal. That is really, really fatal. Okay, so why does this happen? First off, let's put this back on the left-hand side, just to be safe, even though it shouldn't matter anymore. And let's see. Test conditions. The other thing is, are these all going to fail like a different function every time, or is it the same function? Yeah, different functions failing. So we've even got a race condition about which one overflows its stack first, which is beautiful. This is a great layer cake of potential tomfoolery. Okay, so what is going on? What is going on? How do we deal with this kind of problem? Why is this still recursive? Like there's nothing recursive about this anymore. Dotted fields. What is a dotted field? Dotted field is just identifiers. Resources about language design. I mean, there's Crafting Interpreters by Robert Nystrom, I think his name is. That's a really good book. I've got it on my bookshelf. I haven't read much of it. Hold on, let me... The other classic book that kind of touches on it is Structure and Interpretation of Computer Programs. This is actually, I think you can get the whole book for free. Structure. Oh, SICP. Sorry, I'm always bad with these. But yeah, these are two really cool books that are worth reading. Not about language design. Oh, like the actual, like why you make certain design decisions. I don't think there are books on that. I think it's, yeah. Is there anything on compilers, not interpreters? That is a good question. I mean, there's the Dragon book, right? That's the one everyone talks about. Yeah, this one. The Dragon book. It has a really great cover. Look at this. It just screams quality. Yeah, so this book's really good. Man, I should really like maybe this is a good, like, you know, cut the dragon out of this. Maybe this is a Twitch emote. Okay, I'm getting distracted. Dotted field gets an identifier. That's fine. We're allowed to do identifiers. That shouldn't be recursive. So why does this go forever? Unless it's actually this. Unless it's because I need to take off 2. Let me just do this. Let me see if I can just massively cut down the scope of this. Does this still go forever? Okay. What if I give an empty slice? What if I say 0 to 0, right? Empty slice. Does that work? Still overflows. Okay, well that's good to know. That's good to know. People more like this. Some languages I normally just cease family and function languages. Yeah. Yeah, I don't think there's like a book you can follow, right? I think you just have to have a vision. I think it's more, it comes from within. Right? There's lots of stuff about the technical details, but the actual design, I don't think there's a real science to it. But if Kuviman is who I think they are, that is a very cool stream, and it's worth checking out once I'm done, of course. No, of course, I'm being silly. What? Okay. This is really bad debugging, but I'm just gonna do this as well. So the problem isn't this, right? The problem is not this recursive call. The problem is this recursive call. LLVM is a pain. I'm interested. What do you think is painful about LLVM? I have not done LLVM. I've never targeted LLVM. Never written a compiler before this. If you can't tell. But yeah, interested. Like, what's wrong with LLVM? And yeah, you can always just spew out a raw binary. It's fun. Okay. So, have I broken something else? Yes, I've broken something else. That's cool. Wait, what? No. That's not right. What did I do here? How did this happen? Okay, well that's good, right? That's good. What the hell? What did I do? What did I do wrong? Why has this suddenly started blowing up? What did I change? Left hand side, right hand side, bin op left hand side, variable bracketed. Can I just cut out assign deref? But they're different every time. I'm gonna cut out expressions until this stops happening. Or it starts erroring. Overflowed stack. What did I do here? That's so weird. This is such a weird regression. Let's keep cutting out expressions. Stack Overflow. What is going on? What did I change? Have I touched anything? Did I change something in my statement parser by mistake? Did I bump a button? If while deref struct fields assign. Like, it's got to be this, right? Stack Overflow. What is going on? Expression variable. Is it putting me here for a reason? Unused. That's okay. So, like, I'm so baffled by this. So all we're gonna do is parse a number. Overflowed at stack. Am I like... Is my computer broken? Like, do I need to reboot? Like, this is so weird. What have I changed? What have I changed in lang source lang? Okay, I wrote fields expression, struct fields, build fields expression. Yeah, that's fine. Wait, did I? What? When did I do this? When did this happen? Where did this line come from? I didn't do this. Did I delete this? Was I talking about how important it was to not like to have that line there so that I didn't end up in an infinite loop? And then I freaking like, what? How did that happen? Binop. This has to be the left-hand side. You have to pass... What did I do? What is wrong with me? Okay, well, then let's go down to statements, the main statement function, because that was so weird. That was like the worst brain moment I've ever had. And now we're gonna have expression, struct, fields. Okay, we're gonna test this. And that's better, that's closer. Now, interestingly, oh right, yeah, because it just calls it directly, doesn't it? So that doesn't actually matter. Foo.bar.baz. Oh, well, I know what happened. I know what happened here. I know exactly what happened here. We put -2 in case this was recursing forever. I don't think I've ever had my brain break quite that much in all my years writing code. That was really baffling. Okay, so we're still struggling to parse y.len. We're still struggling with that. And that's okay. That's okay. It's tricky sometimes. We're gonna try to do this, but with the expression parser instead of the expression struct fields parser. And this is an important difference, right? This is saying, well, hey, here's the exact parser you need to use here. This is saying, work out which of the expression parsers apply. And of course, it just passes the first thing that it can, right? So that's cool. I just put my mark there, which was really stupid. Expression. Where are our expressions? I'm going to split these into different files, I think. I'm going to put all my expression parsers in a file called, like, you know, expressions. I think that would make sense. I think that would work. Binop. Where are we? Struct fields. So the ordering here is important. The ordering here is important. And actually, well, no, okay, let's come back to this. But we have to do this first. We have to try and do this first. That's basically what I'm saying. And now it passes. Okay, now let's go a step further and try and do it up here. Up here. If I can please, I never know where to put my cursor for those pastes. It messes me up. I've been using Vim for a long time and it still messes me up. Okay, that's good. That doesn't loop forever. And now we could say, for example, let's try and do this as a statement. Let's say let foo.y equal bar.baz.xyz. Okay, now we should be allowed to do this, and we're just gonna pass this as a statement and see if we can kind of round trip this. Wait, no, hold on. What I actually meant is plus. Hold on. That wrong left-hand side. The other left-hand side. Foo.y. Foo.x.y. This is what I want. This still doesn't quite work. And this doesn't work because... Oh, okay. This doesn't work because... And we can step through this and see really obviously what happens, right? It'll be really, really obvious. You'll be like, man, that was really dumb. That was really silly. Because obviously, right, we're trying to parse a binary expression. So what do? We look first for struct fields. And we find valid struct fields identifier. Then we try and find a binary operation. Well, and then we never try to find a binary operation. So basically, we have to do this first. Here. That is where the cursor needs to be. Okay. Now if I test, it will pass. Or not. We try and parse a binary operation. A binary operation looks for a left-hand side first. And a left... So maybe this needs to be here. Oh yeah, because an expression is a valid left... Sorry. Except this will fail for a magnitude of reasons. We need to do this first. Or maybe like first after the numbers and the literals. There we go. Beautiful. Okay. So that's good. And now we can compile it. So that's really, really good. Let's grab this. Grab this onto our clipboard. We're gonna run up the web version of this We're going to jump across localhost 8K, paste this in, build it and run it, and something blows up. But that's okay. That's okay. We can work on that. We can work on that. We fixed the parser. That's good news. That's really good news. That deserves a commit. Oh dear. Lang, source, several things have happened here. Several things. We parse... We parse them and we try to compile them. We do compile them, we just maybe don't compile them correctly. And that's okay, that's okay. It's all a learning process. Let me just reset this and try and step through and see if I can work out what's going on. So if I look at this, we expect make array to do some stuff, to set up a pointer. Because I don't have malloc or anything yet, I just make up a memory address myself. So it'll be 4096. This is the address that the struct lives at. So when we say y.len, what we really want is address 1000 plus the offset of this field, which is 2. So we want to deref 4098. So this is all going to happen. We don't have a memory viewer, which makes this a little bit annoying. I'm just going to look for where we return, which is imminent. Cool, so now we jump back. We're about to call another function because we're going to try and set this thing to 82. Now y should also be pushed to the stack, and we see it is. We see it is. This is good. This is the thing that we want. We're going to jump any second now. Here we go, here we go. So now we're in this function. We're going to load stack offset 4, and then we're going to have to load a different one. So 4 is probably the number 82 into C. This is good. Then we're going to push it because we're silly about registers. We have no optimization, right? Everything goes through the stack. And then we get the right address, so that's good. So we're going to pop the value. We're going to store it at address C. This is perfect. So that's absolutely perfect. Then we should jump back. And now we jump back into main, which is good. We push A. So A... I don't know, A is nothing. A is just like whatever. That's actually, what ends up in the A register? Okay, so I think part of what's going wrong here is maybe that we've returned a value, but like we're pushing it to the stack, but actually this function didn't return a value. Like we should just ignore that. We should not push the A register. We should in fact pop. Oh no, sorry, that's what we're doing. That's what we're doing. Is it? Yeah, we push it and then we pop it. Okay, that is very, very silly. This code could not be sillier. But that's okay, that's okay. This is the starting point. We're only going to get smarter from here. We're going to load something from C. Now this should be stack local, which is good. So this is the number we want to see in register C. This is the address of our struct. So what we should see is we add 2 to this. So we're going to push it, then pop it. That's okay. So this is wrong, okay? So we're doing this one too many times. So because this is a pointer, we're trying to dereference it, but actually we shouldn't be dereferencing it. We should just be adding that offset. Let's try and do it. Let's try and do it. Let's see if it works. Let's see if we can just make it happen. So I want to go into deref, field deref. One of these is too many. Let's just see if we get rid of this. If we get rid of this, is it actually okay? Okay, let's go back. Build, run. Something similarly strange is going on here. 1, 2, 3, 4. 1, 2, 3, 4. 1002. Hold on. That is actually the right address. This is exactly the right address, but at some point, load word. Oh, it's the wrong format for this instruction. This instruction has a really stupid order of fields. I think I need to do this. I think it's CC0. I think. Yeah, there we go. Now we end up with 82 in the A register, which means that we returned this value from the function as expected. Perfect. So that's it. We compiled a function. It did some struct stuff. We set one of the fields, and then we can see it come back out in the A register. We're gonna turn this. We're gonna get rid of this foo definition. I don't know what that's doing there. We're gonna turn this into a test. We're going to turn this into a test. We're going to go into tests, lang tests, struct. We've got a struct. And then we're going to, oops, wrong clipboard. Let's do this. We'll copy and paste this random stuff. We'll make a test, struct, field set, I guess. That's okay. Let test equal this, and then we just need to run it. Yep, no, that was actually right. It's just a thing too many. Beautiful, beautiful. So we want to make sure the thing in register A at the end of this is 82. And now if I test, it will pass. It'll pass. It'll foo, unknown type foo. What's going on there? Oh, main returns a foo, not an int. That's, of course. Obviously I did that. Nice, so that works. Let's just add lang, and we'll just add that to the, oh, I didn't actually commit previously because cargo was yelling at me. That's funny. So let's commit that properly now. Yeah, let's commit that properly. Excellent. Perfect. Okay, so let's have a look at my goals for the stream. Let's have a look at what I set myself. Struct right-hand side field derefs. Check. We did that. We did it. Nested structs, untested. It might just work. Nested structs might just work, but we need to do this before we can be really sure that this is like properly done. And then we also need to port this to the left-hand side because this was a much smarter way of doing it apart from the parser shenanigans. So this has been fun. This has been a journey. And structs are turning out to have a couple of sharp edges, but it's been a good journey. It's been very rewarding. It's been very, very rewarding. I think that's all I can handle right now. I'm gonna have to go make some food, make some dinner, but I'll throw the love onto another streamer now. Let's see if we can find a good stream to raid. What if I'm always happy to take recommendations from my chat if anyone has any kind of favorite. Is Kuverman streaming? That sounds good. How many viewers? 29. That's acceptable. That is an acceptable. Oh yeah, I rated this guy the other day. Let's do it. Let's throw him over here. Let's keep the lang chain going. So awesome. Thank you so much to everyone who's been tuning in. Thank you to everyone who's been watching on YouTube, especially the people making it to the end. I know I see you out there. And thank you everyone for all your help and all your comments and all your discussions. We're making great progress in no small part thanks to the wonderful people who are helping me on the journey. So it's been great. Looking forward to a lot more, and I will catch you next time. See ya.